This video covers review 12, pages 1 through 5. So everything that will be on the test 12 is on this review. This video is about to cover the entire review. So problem 1, we start by being asked to simplify each expression. When they ask us to simplify, they are asking us to get rid of parentheses and to put things in the smallest terms. So first, to get rid of the parentheses, I distribute -3 times x and -3 times -4, which ends up being a positive 12. I also distribute x to 2x, so 2x squared because I have x times x, and x times 3, which is a total of 3x. From here, I'm combining my like terms. So I'm looking through everything that I wrote, -3x plus 12 plus 2x squared plus 3x, and I'm looking for any repeated x squareds, x's, or numbers. So I have 2x squareds here. I don't have any other x squareds. I have 3x's here and 3x's here, and I have 12 for my numbers. So combining my x squareds, I just have the 2x squareds. 3x minus 3x, or -3x plus 3, cancels out. And then we just have the plus 12. Some people do like to put plus 0x, but it's really unnecessary. And actually, some people forget to put the 0, and then that's really an imaginary 1, which is not 0. So I don't recommend it. Problem 2, we're doing the same thing. We're taking 2 times x, 2 times -4. -3x times x, which is -3x squared, and -3x times -5, which is 15x. Again, combine like terms, so I have -3x squared, 2x's plus 15x's, and -8. So I have -3x squared, 15x plus 2x is 17x, and then -8. For problem 3, I distribute 4 to everything inside of the parentheses. This is where you can do a smaller box to multiply if you want, or you just distribute. So 4x squared, 4 times -4x is -16x's, and 4 times 6 is 24. And then I take -2x times x, so x times x is x squared. -2x times -5, -2 times -5 is a positive 10x. So this one has a lot more terms. Again, I'm only combining x squareds with x squareds, x's with x's, and numbers with numbers. So on my x squareds, I have 4, and I'm taking 2 away. So in my calculator, I can put 4 minus 2 and get 2x squareds total. Remember that the only time your exponents change is when you're multiplying. After you've multiplied, after you have this step, you do not change exponents anymore. You just change the numbers in front. -16x plus 10x, so -16 plus 10 is -6x. And then 24 stays. Problem 4 asks us to find the product, and this time we have 2 parentheses being multiplied together, so this is where we would use the box. In class, if you were in class, you should have received a couple half sheets of boxes if you want them, so you can do that on the little half sheet, or you can just write it here. So x plus 8 times x minus 3. Remember that the signs do go with the number that follows. So to fill in my box, I have x times x, which is x squared, 8 times x, which is 8x, x times -3, which is -3x, and 8 times -3, which is -24. Now, as we found, as long as you set these up, there is a pattern where you can add the x's on the diagonal. Remember, if you do not set it up this way, you should still be able to combine like terms. The x's are the like terms that you can combine. So even if they aren't on the diagonal, you need to be on the lookout for that. So 8 plus -3, or 8 minus 3, is 5x's total. So I have x squared plus 5 total x's minus 24 as my final answer. Problem 5 wants us to do it again. So we have our box, 5x plus 1, 4x minus 3. To fill in my box, 5x times 4x is 20x squared because x times x. 1 times 4x is 4x. 5x times negative 3 is negative 15x. And 1 times negative 3 is negative 3. Combine my x's, I have negative 15 plus 4. In total, I have a negative 11. So I have 20x squared, a negative 11x, and a minus 3. Problem 6, use the box again. So remember, anytime you have two parentheses with x term being multiplied, we put them in the box. We make sure we don't break up our terms, so 5x minus 2 and then 5x plus 2. Fill in the box by multiplying. 5x times 5x is 25x squared. Negative 2 times 5x is negative 10x. 5x times 2 is 10x. Negative 2 times 2 is negative 4. Combine my x's, or my like terms. Negative 10 plus 10 cancels, so I have 0 x's, meaning I do not have to write them in my answer. So I have 25x squared and a minus 4 and 0 x's. Problem 7 tells me that the perimeter of a triangle is 8x squared minus 2x plus 6. If two sides are x squared minus x and 4x plus 3, what's the missing side? So we have two sides, and then we have the perimeter, which is 8x squared minus 2x plus 6. So my two sides of x squared minus x and 4x plus 3, and my perimeter. So remember, the perimeter is the full thing. Right now I have these two pieces. So the first thing I need to do is find the total of those two sides. So for the two sides, I have an x squared. I have a negative x and a 4x, so 4 minus 1 is 3 x's. And then I have a plus 3. So I know the two pieces in blue. I know the whole thing in green. So to find the red, I'm going to take the full thing, which is that perimeter, 8x squared minus 2x plus 6, so my perimeter, and I'm going to subtract the two sides, the total of the two sides. Those two sides had a total of x squared plus 3x plus 3, and this came from over here. So we're taking the total and subtracting the part to find the missing part. Remember that when you subtract, you distribute your negative first, so negative x squared, negative 3x, and negative 3. We're subtracting or distributing that because we need to subtract everything inside of the parentheses, and once we distribute, now we can combine like terms. So I have 8x squared minus 1x squared for a total of 7x squared. I have negative 2x's minus 3x's for a total of negative 5x's. And I have 6 minus 3 for a total of 3. So my missing side would be 7x squared minus 5x plus 3. Problem 8 asks us to find the area of a rectangle that has a length of 6x plus 3 and a width of 2x minus 4. So to find the area, we use our box to multiply 6x plus 3 by 2x minus 4. The reason being, area is length times width. So length times width. We have two sets of parentheses multiplied next to each other, so we use the box. Again, to fill in, top times side. So 6x times 2x is 12x squared. 3 times 2x is 6x. 6x times negative 4 is negative 24x. 3 times negative 4 is negative 12. Combine your like terms. So 6x's minus 24x's is negative 18x's. So for my total, I have 12x squared minus 18x's minus 12. Page 2, problem 9 tells us two schools are combining their old calculators to sell to other schools. Their inventories are shown below. So we have school A, which is 2/3 c squared plus 4c minus 2, and school B, which is 7/4 c squared plus 1/5 c. Write an expression to show the total inventory for both schools. And again, a keyword here is combining or adding. So this we're basically adding like terms. So we have 2/3 c squareds, and we're adding 7/4 c squareds. So my total c squareds will be 2/3 plus 7/4. So in my calculator, I do 2/3 plus 7/4. Remember, you can do the alpha y equals to put these into fractions, or once you get a decimal, answer math inner. And we get 29/12. That is a really ugly answer, but it is possible. So make sure that you use the calculator because we're seeing some issues of students trying to add things incorrectly with fractions, so be sure to use those calculators. I then have 4 c's plus 1/5 c, so 4 plus 1/5, math inner, and we get 21/5. And then for my numbers, I have a -2 and no other numbers, so we just leave it as -2 or -2. We are then asked to take these and factor completely. So the first thing I do is look for a GCF. They don't all have x's, and we have a 1, 4, and 32. Remember, with 1, you can't take anything out of it, so we will not have a GCF. So we are looking for two numbers that will multiply to -4x and have a product of -32x squared. Remember, in our box, we put in the first term and the last term, and the diagonal is what we use to combine to get -4x. In our table, in y equals, we're going to put -32 divided by x and look for x plus y equals -4 in the table. So this is where the calculator comes in handy. So y equals, we put -32 divided by x into y equals. Look at the table, and I'm looking for a horizontal row of an x plus a y that will add to a -4. And remember, we're only using whole numbers, so 1 doesn't work, 2 doesn't work, we skip 3. 4 plus -8 would give me a -4. So I write my two factors of positive 4x and -8x. So again, these come from the calculator, but as we just did on the front, once you multiply, we combine the diagonal to get our total up here. So we break it back down. So when we factor to finish this out, we undo the multiplication. So we look for that GCF. X squared and -8x share an x. 4x and 32 share a 4. X squared and 4x share an x. -8x and -32 share a -8. Remember, it is negative because the term closest to where I write my answer, or on the outside, is a negative. So x plus 4 and x minus 8 are my two factors there. Problem 11, as I'm looking at these, my numbers have 3, 24, and 21, so they're all divisible by 3. I also notice I have x, x, and x all in different forms of exponents, which means my GCF is going to be a 3x. So I divide 3x from all of my terms, and my GCF goes out front. I also make sure that I leave it in my answer. My answer is going up here on the top, so I put 3x in front so I don't forget. But down here is where I'm going to keep working through my answer, keep factoring. So I take the 3x out and keep pushing. So my 3's cancel. X cubed divided by x is x squared. 24 divided by 3 is x. X squared divided by x is x. 21 divided by 3 is 7, and my x's cancel. So now I have my box. The x squared and the 7 stay, and those make my product, 7x squared. My sum is that middle term of 8x. So I'm going to put 7 divided by x into y equals. Look for an x plus y that equal 8. So 7 divided by x, looking for two numbers that will add to 8. 1 and 7 would do it. So 1x and 7x, both of them positive. You can put those plus signs in front if you want. Looking for my GCF, x squared and 7x share an x. 7 and 1x share a 1. X squared and x share an x. 7x and 7 share a 7. So my factors are x plus 1 and x plus 7. Problem 12, as I'm looking, I have an x squared term, so that tells me I'm probably not going to have any GCFs. Nothing, you can't really take anything out of 1, and not all of them have an x in them. So I'm looking for a sum of 11 and a product of negative 42x squared. In y equals, I'm going to put negative 42 divided by x and look for an x plus y. That will add to 11. I can also start my box. I have the x squared, the negative 42, and my other two terms come from the calculator. So I have negative 42 divided by x. Look at my table. I'm looking for two numbers that will add together to get 11. Remember, they need to be whole numbers. 1 and negative 42 do not equal 11, and I'm looking for a positive 11. That is important. 2 plus negative 21 is negative 19. 3 plus negative 14 is a negative 11, but I need a positive. 6 and 7 have a difference of 1. 14 minus 3 would get me 11. So my factors are 14x and a 3x. So x and 3x share an x. 14x and 42 share a 14. Oh, sorry, my 14 is negative. Nope. My 3 is negative. X squared and 14x share an x. Negative 3x and negative 42 share a negative 3. So we have x plus 14 and x minus 3 as my two factors. Problem 13, I see a 6x squared, negative 54x, and negative 78. All of these are pretty big numbers. I tried them all, and they're all divisible by 6. Remember, if you're not sure, take your calculator and just do a quick check. 54 divided by 6, 78 divided by 6. Oops. Oh, look, they're divisible by 6. So I take that 6 out, and I'm left with x squared minus 9x minus 13. Remember, when I take it out, I am dividing it out. I also like to start my answer with my GCF in front so I don't forget it. So I'm looking for two numbers that add to a negative 9 and multiply to negative 13x squared. So I put negative 13 divided by x. Look at the table. I am looking for an x and a y that add to a negative 9. Remember that I can only use whole numbers. 1 minus 13 is negative 12. None of these are whole numbers, so I skip them. And the only whole number I have is 13 minus 1. Well, 13 minus 1 is 12. But if I got all the way back to my product and I haven't seen anything, then there are no factors that will fit this criteria, which means my answer is just taking out that GCF, and there's nothing further I can do. Problem 14 asks me to write the expression that represents x squared minus 25 in factored form. Remember, there is no x term, so my sum is 0. My product is negative 25x squared. So I have the x squared and the minus 25. I'm looking for two numbers that I can plug in here that will add to 0, so they will cancel each other out. In y equals, I type negative 25 divided by x and take a look. Only looking at whole numbers, 1 and negative 25 don't cancel. 5 minus 5 would cancel. So I have a positive 5x and a negative 5x. So looking for my GCFs, x squared minus 5x share an x. 5x and 25 share a 5. X squared and 5x share an x. Negative 5x and negative 25 share a negative 5. So I have x plus 5 and x minus 5. 15, ask me how to represent that as a product of two binomials. That's basically a really fancy way of saying factor. When I look at these, there's no GCF because they don't all share an x, and the numbers, you can't divide anything out of 1. So I'm looking for two numbers that will sum to 2 and multiply to 1. So in y equals, I put my product of 1 divided by x. Look at my table. The only whole numbers I have are 1 and 1, but I'm trying to find a way to get them to add to -2. If I look up at the negatives, -1 plus -1 would give me that -2, and as we can see from the table, are factors. So I have x squared and plus 1 that don't change, and then from the calculator, I have a -1x and a -1x. Taking out my GCF, I have x minus 1, x, and minus 1. So my factors are x minus 1, x minus 1. So again, it is really important to make sure you're looking at the signs of your product and your sum. I put my product in correctly. My sum needs to be negative, which means I need to either come up with two factors that can add to a negative or look at my negative numbers in the table. Page 3 is more factoring, so let's get going. Factors of this one. This does not have a GCF, so looking for sum of 20, product of 96. Go ahead and set up my box. So 96 divided by x. And I'm looking for two numbers that add to 20. Looking for a positive 20. Oh, 8 and 12 will do it. Okay. So my GCF, x squared and 12x share an x, 8x and 96 share an 8, x squared and 8x share an x, 12 and 96 share a 12. So x plus 8 and x plus 12. 17 asks me to factor the binomial. The first thing I notice is that I'm going to have a GCF because the number in front of x squared is not a 1. So I factor out the x, and I get x squared plus 36. So I'm looking for a sum of 0 x's and a product of 36x squared. So two numbers that will cancel out, but also multiply to a positive 36. In my table, remember, I can only look at whole numbers, and I'm looking for numbers to cancel out. The only numbers that look like they might cancel would be 6 and 6, but they're both positive. 6 plus 6 is 12. So this part is not possible. So this factored out GCF is my answer, because there's nothing I can do further. Problem 18, I notice that these are all even, so I can take out a 2. I also notice they all share an x, meaning I can take out a 2x. I take out that 2x, and I'm left with x squared plus 3x minus 18. Remember, anything that cancels, you don't write it. Otherwise, we're just dividing and subtracting our exponents. So, sum of 3x, product of negative 18x squared. My x squared and the minus 18 pop in here. We look in y equals. Make sure you put that negative sign in there. In the table, two numbers I'm looking for that will add to a positive 3. So that would be negative 17, negative 7, negative 3, positive 3. So 6 and negative 3 are my factors. Take out that GCF, so x squared and negative 3x share an x. 6x and negative 18 share a 6. X squared and 6x share an x. Negative 3x and negative 18 share a negative 3. So GCF in front, factor, factor. Problem 19 asks me to factor completely. Looking at these, we don't have a GCF, so we're looking for two numbers that will add to 22x and multiply to 121x squared. Start my box. x squared, and 121. And I'm going to find my missing numbers with the calculator. 121 divided by x. Look at the table. I'm looking for two numbers that will add to 22. Remember, only whole numbers, so that would be 122. Not a whole number, not a whole number, not a whole number, not a whole, not whole. Oh, 11 plus 11 would give me 22. So 11x and 11x. Looking for my GCFs, I have x and 11, x and 11. So my factors are x plus 11, x plus 11. Problem 20, looking for my factors. I'm looking for a sum of negative 2x, product of negative 35x squared. I have x squared and negative 35. And I'm going to look for my two factors that will add to a negative 2 in the calculator. Remember that if you have a negative product, you need to put that negative in there, and it will help you out with those negative signs. Only looking at whole numbers, 1 plus negative 35 does not equal to negative 2. 5 plus negative 7 would give me negative 2. So 5x and negative 7x. Look for my GCFs. I have x plus 5, x minus 7. Problem 21 asks us to factor this. We have a sum of 0 x's and a product of negative 144x squareds. So in my box, I need two numbers that will cancel out to get 0. So I plug negative 144 divided by x into y equals. Looking for two numbers that will cancel out. This time the signs are, well, the signs are always important, but this time the signs really do play a role. Only looking at whole numbers. This is not 0, this is not 0, not 0, not 0, not a whole number. Not 0, not a whole number. Not 0, not 0, not a whole number, not a whole number. Oh, 12 minus 12 will give me 0. So 12x and negative 12x. Factor out my GCFs, x plus 12, x minus 12. Problem 22 asks me to factor completely. When I look at these, we have numbers that are not 1, but they're all prime, meaning that I can't factor out a GCF, so I just got to do it like normal. Sum is 2x, product is negative 15x squared. Remember, for your product, you multiply first times last. We just haven't had many that worked out like this yet. In my box, I put 3x squared and minus 5. I still plug in my product into y equals. I'm still looking for two numbers that multiply to negative 15x and add to a positive 2. Still only looking at whole numbers. That would give me a negative 2. So how about the other way? 5 and negative 3. So we're doing the exact same thing, but this time because we have a number in front, we're going to need a GCF somewhere that's more than just an x. So 3x squared and negative 3x share a 3 and an x. 5x and negative 5 share a 5. 3x squared and 5x share an x. Negative 3x and negative 5 share a negative 1. So my factors are 3x plus 5 and x minus 1. Keep in mind, as we've said in class, anytime you have a leading number that you cannot take out with a GCF, you must have at least one leading number in your factors. Problem 23 is the same way. We are looking for a sum of 3n and a product of negative 18n squared. I'm looking for this because I know that there's no GCF because 2 and 3 are prime and you can't take anything out of 2 and 3. That would be the same. I put my 2n squared and my minus 9 to my first and last, which I multiplied to get the product. And I'm looking for two numbers in my calculator that will add to a 3. So negative 18 divided by x, looking at my table. Two whole numbers that will add to 3. Not 3, not 3. That's a negative 3, but I need a positive. 6 minus 3 would give me a 3. So 6 and minus 3. Don't forget to put those n's on there. Looking for the GCF. So 2n squared and negative 3n share an n. 6n and 9 share a 3. 2n squared and 6n share a 2n. Negative 3n and negative 9 share a negative 3. So 2n minus 3 and n plus 3. Remember that on your test, the order in which you write the factors does not matter as long as what's in parentheses is the same as what we have. So if you flip your parentheses, you better have n and a positive 3 together and 2n minus 3 together, just in the other order. 24 is a review question. It asks us to evaluate the expression of 7x to the third cubed. So you can write this out 6 times, or you can distribute. 7 gets a 6, and x cubed gets a 6. 7 to the 6 we put into our calculator, and we get 117,649. These are piggybacked or right on top of each other, so 3 times 6 is 18. And again, remember, you can stamp it out, write that thing out 6 times, and figure it out the same way. 25 asks us to simplify this. We have a negative and a negative, so I'm going to rewrite, leaving everything where it is except take care of the negatives. X to the 5 comes up, y squared goes down, and remember, after you move them, they become happy. Numbers, I have 8 divided by 24, and we get 1/3. So when I start my fraction, I will start with 1/3. My x's, I have x cubed times x to the 5th, all on the top. I add my exponents. 5 plus 3 is 8, so I have 8 x's total on the top. My y's, I have y squared and y squared on the bottom. But because they're both on the bottom, we add. We keep them on the bottom because remember the y's were not happy on the top. And then for my z's, I have z divided by z, which cancels, meaning I have no z's, and this is my final answer. (26) asks me to graph the equation below. I can't graph until I know what y equals, so I move x to the other side first. Negative x and 12 are not like terms, so I simply rewrite them. And then I divide everything by 4. So y equals negative 1/4 x plus 3. When I graph it, this is my beginning on the y-axis. And this is how I move. The negative 1/4 means I'm going to go down 1 and to the right 4. So I begin at 3 on the y-axis, and then I move down 1, right 4, down 1, right 4. And I draw my line. 27 asks me to solve for x, so first I distribute. 2 times 3x, 2 times 2. Negative 4 gets distributed. Negative 4 times x, negative 4 times negative 7. And 8 gets distributed. 8 times 2x, 8 times negative 3. I combine any like terms I have. 6x's minus 4x's is 2x's. 4 plus 28 is 32. I do not have anything to combine on the right side. Then I solve for x. I have x's over here and x's over here. I need to get them on the same side. So I move 2x to the other side. Remember, anytime you cross that equal sign, you have to do the opposite. Still trying to get x by itself, I move 24 to the other side. So 56 equals 14x. And I finish by dividing everything by 14 and get that x equals 4. 28 asks me to write a function that represents a line that contains the point 3, -2 and has a slope of 5. So I'm given a point, which is my x1, y1, and a slope, which is my m. Remember that point slope is y minus y1 equals m x minus x1. So we plug in what we know. Y minus -2 minus negative means plus. Slope is 5, x minus 3. If they want it in slope-intercept, we need to keep going. 5 times x, 5 times -3. Move 2. Remember, we only put it with like terms, so the 5x does not change. -15 minus 2 is -17. 29 asks me to graph y is less than x plus 4 on the graph, and then tell me which one of those is a solution. So I start at 4. X means I go up 1, right 1, up 1, right 1, up 1, right 1. This is dashed because there's no line under the inequality. And y is less than 4, less than is lower, so everything lower than the line or underneath the line is in my solution set. My point is -7, 0. That's not in my solution set. -1, 3 is on the line, but the line is dashed. 3, 9, not in my solution set. And 2, -4, very clearly in my solution set. So we're looking for the one that's in the shaded area. Problem 30 says a group of students are going on a field trip. If the students take 3 vans and 1 car, they can take 22 people. They have 5 more vans than cars. Write a system that can be used to find C, the number of people that can fit in each car, and V, the number that can fit in each van. So the first piece of information we have is that 3 vans plus 1 car can take 22 people. And then we know that there are 5 more vans than cars. If there are more vans, then we put vans on the outside and do 5 more than cars. So my vans equal 5 plus my cars. 31, the function y equals 50 plus 10x can be used to describe a food delivery service that charges $50 to sign up and $10 for each delivery. If Carla's budget for delivery is at most $100, write the values that represent the domain. So y is used to describe the service, and y is going to be your cost. Okay, so if we're describing the domain, we need to find out what those x values can be. The delivery budget is at most 100, so y is at most $100. So we need to figure out how many x's we can get in for $100. So I'm going to take that equation, 50 plus 10x, and put it in y equals, and go look at my table. I'm looking for where y is 100, and it's right there when x is 5. And I can do anything up to 100, which means I can do anything up to 5 x's for deliveries. So my domain is going to be anything 0, 1, 2, 3, 4, or 5. Note it is not 0 to 5 because you can't have in-between numbers. So you can't have 1.5 deliveries. You have a delivery or you don't have a delivery. And you can do at most 5 deliveries. You could also do 0 deliveries and pay to sign up and never get anything delivered, and then you've wasted your money. You can do anything in between wasting your money and the most deliveries possible.